little thing did pop up in the upper corner. It says live, so we're live.
We're finally live, and it's like 10 o'clock, 10:01. We're not too late to this.
Yeah. So you see some eyes out there?
Maybe. We'll see how it goes. Let's just assume that there is.
Assume they're out there.
And because this is the first time we've ever done this, and you know, the premise is tried to, you know, first off, just kind of talk about obviously a little bit of, you know, coffee tech stuff, espresso machines, all the way down to, you know, the farm level. If we're going to talk about calibrating depulpers or whatnot, it's all game. But you know, kind of start with what we know and who we know. And, you know, since we're kind of like closely geographically positioned in the Midwest, and Marty, you know everything out there is to know as far as from my perspective, you know. And
all I have to know is a little bit more than you on any given subject on any given day, and I can impress you.
Yeah, and I know enough to be dangerous, not enough to know to be safe.
Trust me, I can relate to that. Absolutely.
And so, like, I think it's kind of like a good middle ground where we can, first off, I'm going to try to see, like, we're going to have some discussion for about 15 minutes and then kind of open it up to see if anybody has any questions. And then I'm going to try to see if we can invite them to the conversation through adding them to the Zoom call, which is pretty simple. I can simply just invite whoever would like to come on if we have a good question or if we need that. Might save that for the next time if we have a difficulty with the technology, but you are definitely a technician, and I'm a pocket scientist kind of technician of sorts, where I guess I know enough to know what a solenoid valve is, not exactly how it works down to the exact science of it, but I think that's what this is for. It's a platform where people like myself who have, you know, worked with espresso machines and grinders and roasters, but kind of lack the connection between, like, how does this actually work and what's going on here. And so today I have the best, I think, a nice little slideshow, little PowerPoint that I'd like to present to you. You haven't seen this yet, everybody? Marty,
have not seen it. Total surprise. It's like John, it's like walking in on a service call and they said, our machine is down. Well, and that's all you get.
And this is exactly what happened. I was out on a service call, a mild one. I do mild things, and came across this, and maybe they're watching today. I hope that they are, because I kind of wanted to bring this to the table and said, like, I'm gonna ask a little bit more about this and what's going on and see how we can fix this, because it seems to be a systemic issue, not necessarily with the machine, but maybe it is. I don't know. Well, I have my sneaking suspicions to what it is, but I don't want to give it away. And maybe someone will.
So John, just for clarity, you haven't fixed this machine yet? Is that correct? It's still out there broken?
No, the hot water assembly was installed properly and it is now working. And I just kind of gave it away. Ugh. Not totally.
I didn't hear anything. So yeah, let's I'm ready for it.
Yeah, it's not totally
okay.
All right. So
while it's doing that, I wanted to thank you for doing this online tech talk thing. I think, one, it's going to be a lot of fun, and depending on who all we get involved with it, it has the potential of really connecting a lot of people and sharing a lot of information. So thank you.
Yeah.
Thank you.
Well, do you see it yet?
I do not. I see your smiling face.
All right. Well, let's see if we can do it again. Remember, this is our first time we've done this, so I'm going to try to do a screen share and go into the PowerPoint and share it.
Boom. I do see.
And it's the full.
If our multitude of fans out there see it too.
I think so. So can you read what's on there?
It says what happened here, and what it looks like to me is a cup maybe with a little bit of water that's tinted in the bottom of it. Is that correct?
Yeah, that's right. So like I went down to correct the the hot water assembly was basically just not working. You toggle switch, no power. the magnetic coil, the black box was completely burnt out when actually they had shut the machine down. Obviously, with the pandemic and the COVID, a lot of people were shutting the machines down for a while. They turned the machine back on, and the thing started on fire, shut it off. I went down there, I disconnected the wires, kind of covered them up so no one would get hurt. And then I ordered a hot water assembly, about a month later, and said I can install this for you, at a pretty decent price and get down there. And so I switched it out and noticed that with the steam coming out of the wands and it was a little wet. So the fill valve was completely full. Steam tank was completely full. Corrected that too. Got it out, cleaned it up, and now it has a nice level. But the hot water assembly, this is what came out of it, and it also came out with the steam wands. And this is like a creamy, it will not settle. This is like a solid mixture of like that creamy texture, and it's a darker liquid. And I drained it once, I drained it twice, the steam tank. I'm not even giving anything away. I mean, you know how this stuff works, but we'll explain this actually in the next couple of slides of exactly what we're talking about. But so what happened here?
Well, obviously you don't have pure water in there. That whatever came out of that's got other stuff in it.
What might that stuff be?
Well, from my experience, it could be the first thing that I would question seeing an amber-like water coming out of a steam boiler is, have you recently changed an ion exchange water softening cartridge that feeds this machine? The reason I say that and going down that path to eliminate that as a possibility or confirm that's a possibility is that if you don't flush your filters, they tend to slough off material during the first few gallons of running water through them. And that's a pretty close example of what you would see if you had a sodium ion exchange water filter that you didn't flush and you filled your boiler with that. So that's one possibility. The other possibility is that over a long period of time, 6 months or more, if you're using this steam boiler on this machine and never taking anything out of it other than the form of steam, the actual minerals that do naturally come in as you refill that boiler each time are going to be trapped in there. So it just could be a natural elevation of minerals. We call that TDS, total dissolved solids, not to get too technical, but it could be just a natural rise of these minerals in a boiler that's not been maintained by getting rid of that water periodically. The third thing is, and it depends on if there was a catastrophic failure of a heat element, it could be materials actually off that heat element that has dissolved into there. I don't think so on that one, because typically those would settle out as they discolor the
Yep.
So
well, I think
I've hit three things there.
I think you nailed it. I think that there was a soft water softening kit that was installed in the water line, and there was some discussion about adding salt periodically. I spoke with another friend that works in plumbing and HVAC and whatnot, and like water systems, and he was familiar with soft water, soft water, and this could result in a filter or something like that. So I think what you just explained was exactly probably what was going on. So I guess the recommendation is what should they do other than obviously draining the boiler, kind of cleaning out the boilers to prevent this from happening? Just get rid of the soft water kit and get a different filter. What's the corrective action here that you can take?
Well, not going down the rabbit hole, knowing or testing the water and finding out. 5 minutes. I'll keep it concise. We're assuming that whatever filtration system that's in there was applied accurately and that it's the right water filtration for that. So let's just assume that. That's a whole nother discussion. I wouldn't get rid of the softening. The water needs to be soft. We need to get the calcium content down, get that concentration down so that it doesn't affect the machinery, if you will, doesn't build up. So you say, do we get rid of it? No. What we need to do though is we always recommend, you talked about your hot water spigot. They may have been having problems with that for a while. That hot water spigot, I recommend absolutely use that. There was an article not too awful long ago in one of the trade magazines that indicated some reasons not to use that hot water spigot for consumables.
Well, they always say like stresses the machine out, you know, you don't want to wear down, you know, like the lots of like power and consumption and, you know, you're stressing out the heating elements. Are those all just like falsehoods, you know?
That particular thing is a falsehood. These machines are designed to run.
Yep.
They're designed to absolutely run. And like I said earlier, if all you're using out of that steam boiler is the form of steam, the water that's in there acts as a trap for any minerals to build up. So the only access or the egress of those minerals to get those minerals out would be to use that hot water spigot, because there's a dipper tube that goes down into the bottom of the boiler that's picking up water feeding that hot water spigot. So you're actually pulling those minerals out in that form, and you're going to be replacing it with fresh water. Right. The other recommendation would be anytime on the regiment of the time that you change your filters, we highly recommend totally drain that steam boiler and let that refill with fresh water. So that helps you. That's another layer of defense in the case that you're not using enough hot water out of your spigot to maintain a clean boiler, if you will. So those two items are big to flush your steam boiler anytime you're changing the filters, and then utilize that hot water spigot as much as you possibly can. I recommend use it to rinse your shot glasses.
And I think that's a great review. And I think the next couple of slides we're going to go into a little bit of the schematics of a boiler, specifically a double boiler on a linea, just so we can kind of like get the several people that are watching live, and also the people that will be watching in the future, about what are we actually talking about here as far as like how does water go through a machine and how does it work. I got a couple things going on, but I like this little photo here. I took a picture of that. That is a solenoid valve assembly. That there's the stem valve, and then there is the magnetic coil. Is that what it's called?
That's good enough. I mean, there's a lot of terms for that, but that in layman's terms, that does it. That does it for me, John.
Yep. And would you say that that's in good working condition?
Not that one.
That was hard to pull out. I mean, usually, like, you know, you can kind of pull them out, but it smelled like gunpowder. It was sort of like you know, not like that I go around and shoot a lot of shotguns, but I have in the past, and like after it's definitely smelled like a dirty like a recently used shotgun or something like that.
Sure.
I think it's because this is the one that caught on fire.
Well, that would explain the smell.
But I don't know if you see my my arrow
cursor. Sure.
Yeah. But on another valve assembly recently off of Estrada, this thing was leaking. There was like a little pinhole right there, and there was a little drip of water coming out. And I was wondering what caused that to happen. Was it the manufacturing of the stem valve, or was it some water or electrical or magnetic, or what would cause a stem valve to start bleeding out of a little cracked little pinhole?
Well, obviously there could be some manufacturing defect within the metal, maybe an impurity or something that caused that to deteriorate and create that pinhole. The other possibility is that's pretty thin right there. So if you've got any water that's extreme, not really two specs as far as alkalinity, pH, that sort of thing, it can be aggressive, and it can actually start pitting boilers, lines, and the metal that's within that stem right there. That has a plunger that slides up and down that actually does the opening and closing of the valve. And so there can be a wear spot in there, but more than likely it's either a
manufacturing
defect or the water has been a little too aggressive. And what you had was a chain of events. The leak started first. Those coils aren't designed to be wet. And there's tiny little wire wrapped hundreds of times around a spool inside that black box there. And they're tiny. And what you end up with is small electrical short inside there. And it just burns it up. You saw that.
Yep. And so this is, I'm trying to find my cursor here, but that's where the hot water valve assembly is located on this
lower right-hand corner there. Sure.
Right-hand corner. And this is my recently rebuilt Linea Marzocco 2 group. Loving it.
You did a good job on that, by the way, John.
Yeah, it looks beautiful. Thanks, Marty. And I don't have any photos of the blowtorch that it took for the extraction of the heating element out of the steam tank, but maybe we'll do that some other time.
when you have to be heroic, that's what we do.
But this looks like I've always been extremely intimidated by this, until getting in there and taking it completely apart, putting it back together. It really gives you a little bit of insight of how things work. It's one thing I would say as a disclaimer. This is to be sure that you understand the risks involved, and also like how this machine works. Power as far as electricity and water are extremely dangerous, and I highly do not recommend doing this without some sort of like background and training, technical aspects. I've been doing this for years, not at your level, Marty, but enough to know to unplug the machine when you're playing around with electricity, and also
absolutely
where the hot spots are. So Marty, you want to add anything to
that? And in all of our classes that we teach, you will see not only do we have curriculum that is specifically focused on just safety, but we have snippets of safety through virtually every bit of course that we teach. So it's safety is a big thing. So if you have any concerns at all on whether it's safe or not, it's probably not safe, and you should probably consult some guidance.
Probably next time when we do this video, we should start out with like, hey, my name is John Ferguson. I work at the Arbor Day Foundation, and I work with Arbor Day Coffee, and I also do some work with the U.S. chapter, North Central Regional, the SCA U.S. chapter that's been recently formed about 1.5 years ago. And we're trying to kind of promote a little bit more activities like this. And Marty, who are you and what do you do? And then let's move on. And then, maybe I'll edit this and put it on the front. I don't know.
Sure. Yeah, we're learning as we go. I'm Marty Rowe. I'm from Kansas City, Missouri, born and raised. Got into specialty coffee. I'll back up because it makes sense. I was born with a crescent wrench in my hand. So many people have heard me say that. And I almost literally believe that, because I've never not wanted to tear something apart and tear into it. And got into specialty coffee late 99, early 2000, and saw the equipment, saw the people, and one thing led to another. Within 3 years, we were making a living 100% off the coffee industry, trying to put back to it what we can offer. My goal was to be the kick-ass drummer in a rock and roll band kind of thing. The rock and roll band being the coffee industry, and I wanted to be that support in the background, not be a big out front thing, but
actually, I want to talk about that as far as like what is being a technician in the industry. But let's get through these slides, and then I want to get back to that. because I want
So
to
anyway,
about.
that's me. So I'm ready to move forward.
So I've got this screen up and you see it, it says double boiler, right? And then I have a
Yes,
steam
it does.
and I have coffee. The steam is like a pressure cooker. That's how I basically, and then the coffee boiler on the front is fully saturated. What does that mean? And what are the functions behind that? So basically this is a linear, again, like a lot of espresso machines have one single boiler. They're drawing hot water from the bottom or, steam from the top. And this one has sort of a dedicated steam tank on the back and a dedicated brew boiler in the front. That's basically, these are all, fittings, and we're talking about, you said the fill probe is here. We probably don't have enough time to go through everything, but I would like to just simply go through, maybe Marty, you can kind of like be the one that kind of draws us through how water flows through a machine. The next slide will be the one that maybe we could use. This is actually a pretty good one. I should have probably done my little PowerPoint artwork on this one. But this is schematics this is a hydraulic assembly from from a Linea of La Marzocco. And here's you can get this on, was it like lamarzocco.usa.com, and just kind of go under espresso machines and then kind of go down. You'll find the parts catalog and be able to kind of see.
I think it's under their support pull down menu.
Yep. So a lot of stuff going on there. So this is how water flows in the machine. Do you like my little external pump?
I like your little drawing there with your external pump. That's
This
not to
tap
scale.
Water, or, it could come from an actual water filtration system, RO, whatever, with a mineral kickback or whatever. But basically this is the water coming in, and there's an external pump here. And then the water, that's a crinked line. That's not good. Goes into the water intake, and then it's split into two different directions. Right? One of the directions goes into the steam and the other one goes into the coffee boiler. Is that correct?
Yeah. I can kind of summarize this whole thing.
Why do we do this?
Why do we what?
Why do we have that external pump? And I guess start from the beginning, and we've got
the whole
minutes one too.
Well,
So
let me back up just a little bit. It's not rocket science. Basically, we're just heating water and pushing it over coffee. So we have to have a boiler that produces water of about 200 degrees to push it through the coffee grounds to make our espresso. Another function of an espresso machine is we steam our milk, and so we need to have some sort of way to steam milk. So you could either have a single boiler, which you're not starting with that, but you could have a single boiler that's solely dedicated to build steam that robs some of that heat to heat up through what's called a heat exchanger, not the water out of the boiler, but just the heat off the boiler to do that. But a lot of your better machines will have what you're depicting here is a double boiler. So starting out with a hydraulic of the coffee side of it, or the espresso side, you said that was fully saturated earlier. And what that means is that there's no air gaps in there. What water comes in, travels through all the way up to the final little brew valve that's pretty near the brew screen in the head. That's going to be pretty close to that. And water is pressurized and is always there through the boiler, always there. Fully saturated means it's flooded. It's totally there. And so when a brew valve opens so that you actuate it to pull your shot, you're just opening up just a short distance of between the brew valve and your coffee.
And it's not pressure, right? So city water pressure is just like 3 PSI. It's like, you turn on your sink and
exactly
the flow. So we need 9 bars of pressure. Everybody's talking about 9 bars. Well, you can do pressure profiling and all that stuff. And we can talk about that later, but basically.
Yeah, so you said, why do we need a pump? Well, if we could guarantee what's coming out of the water was a consistent pressure all the time, if we knew, and let's just pick 9 bar because that's the industry standard for the ideal pressure for our extraction. If we knew we had 9 bar of pressure, which is just the European version of PSI, if we knew we always had it, we wouldn't need a pump. We wouldn't need it at all.
Exactly.
It would be fine. But what that pump does is it says, okay, I will take whatever water pressure I've got coming to me. I don't care what it is. And I'm going to regulate it. I'm going to either build it up or bring it down to the pressure that I want, which is 9 bar, and that's what we extract our water with. So that's really the purpose of that pump, and that in essence is a hydraulic side of the coffee side. Now on the steam side, we can't have a flooded boiler, because what happens is when we reach our boiling point of water, it turns to steam. And when that water turns to steam, it expands 1,200 times. And so we've got to have some room for that to happen. And so there's a couple features in a steam boiler that's not in a flooded coffee boiler. And that is some device that's going to turn on and off to fill the boiler as we want it, which is, you kind of have an arrow pointing there to that solenoid valve. That's the valve that opens and closes. And so you're basically automatically controlling a level within that boiler that's not completely full. So there is some gap for that steam to expand up into. The other thing that's incorporated in a steam boiler that's not in a coffee boiler is a probe that senses that level, that through some brain work or electronics, it turns power to and from that solenoid valve that's actually filling the boiler. So we've got a water level or liquid level probe that's sensing how full we are, sending that signal to the brain that processes it, and it tells that fill valve whether to open or close to maintain that level. So that's it in a nutshell.
And we've got like a couple more minutes, and I wanted to really touch base on like the SCA, the Technicians Guild, all these other things that are happening. Like I think being an espresso technician has, you always said it's been, behind the audience, setting up machines and, but without equipment, you really can't brew coffee. What did I put like as the whole introduction to this thing? It says like, if you get by with a hammer and cold tap water to brew coffee, perhaps you don't need to join us, but we would highly recommend that you do, because perhaps maybe there's a better way. And, we're talking about preventative maintenance, all these things that are essential. And without coffee technicians, we'd be in a really bad place. And I think that like I think of this, there's a strong future for coffee technicians everywhere.
I do inherently have a need to be needed, so that I'm glad to hear you say that.
How do you see the Technician Guild, or even the presence of like the popularity, or if people want to get into coffee, I always say get a degree, or get an electrical, get some plumbing experience, and there's a lot of work. I don't know right now, it might be a different scenario, but how do you feel about the growth and the potential of job creation in the technician?
Well, right now is a great time to be thinking about stepping into that, because there are some avenues in which you can learn. Obviously in a cottage industry such as the coffee industry, you could just go to work for an existing tech company, and that's a great pathway to go. You're going to learn from them, and baptism by fire. When you're out there trying to figure it out, you got to make it go. You will figure it out. But there's colleges have existed on the concept of it's good to have formal training, and I agree with that. If you're learning everything baptism by fire, it's a tough road to go down.
Too much
So just a few years ago, the creation of the Technicians Guild through the Specialty Coffee Association has moved a big way in creating pathways or an avenue in which technicians can learn some things. And in fact, there's a class going on right now this month, certifying teachers for that curriculum that's being generated. And there's a team of people across the world, really, that are working on content that is going to be presented, and in a very formal yet approachable manner. I'm in that class, and to get hopefully will get me certified so that I can teach that curriculum. Regardless, Workbench Coffee Labs, a little plug here is we are getting geared up. Historically, we've been a barista skills, roasting, green coffee buying, Q grader certified lab, teaching all of those curriculums. There's a lot of places, a lot of places around the world and in the US that also teach that, but very few people are teaching the technical side of it. So because we, to answer your question, right dead center, because we feel that there's a huge need for this, we're going to convert Workbench Coffee Labs almost 100% to technical training. And so you're going to see evidence of that moving forward.
Well, you're always ahead of the curve, and we're out of time. So
okay, let's take some questions if we've got some out there.
I don't have any questions. I don't think there's any questions. I guess I took the entire space, and we'll see what happens. Yeah, if there's any questions, now would be the time to ask them. But
now's the time to plug next
time. Everybody's at work doing something.
I don't know. We'll carve that out. Let's stay consistent. We'll make it so that everyone knows at 10 o'clock on Tuesdays, this is the place to be.
Not only that, maybe we'll get some guests to kind of join us, and we'll see what happens. All right. Well, hey, Marty, thanks for joining us.
This has been fun.
Yeah, I think I learned something. Always learn something new when I'm talking to you. All right. Have a good one. Thanks.
All right. Thanks, John.
Bye.